So much as we started week 2, we're now going to go through the core concepts of CrewAI, the sort of building blocks to understand how it works. And there's some similarities. First of all, there is an agent. An agent is basically the smallest, the unit of work, an autonomous unit, which is related to an LLM. It has an LLM underneath it, and it has something called a role, so a description of what it does, a goal, and a backstory. And it can also have memory, and it can have tools. And that is how an agent is defined. And you can remember back to OpenAI Agents SDK definition. There is something new here. A task is another thing, and there wasn't an analog in the last framework. A task is a specific assignment that is going to be carried out. It has a description, it has an expected output, and it has an agent. So a task is assigned to an agent. So that is the distinction, agents and then tasks, and there can be multiple tasks for an agent. And then a crew is a team of agents and tasks, and that is simply, so a crew is the aggregate of the other two. And a crew has two different process modes. One of them is called sequential, and that is where it will simply execute each task in turn as it's laid out. And the other is called hierarchical, and that is where an LLM will be used, a manager LLM, in order to assign tasks to agents. So those are the two different modes that you can operate in. So that gives you, these are the 3 core concepts to keep in mind. So how do we think about this? So these are lightweight concepts, and they're certainly reminiscent of last week. I would say that it is a bit more opinionated than the OpenAI Agents SDK. There's a bit more terminology, it's a bit more prescriptive. So as a clear example, if you look at the agent there, if you remember last week, agents just had instruction. An instruction was basically the system prompt, and you provided the instruction. And that's very unopinionated. You can choose to think about instructions however you want. Now, with Crew, an agent has a role, a goal, and a backstory. So it's a bit more, you can see immediately, it's more prescriptive in terms of how one is supposed to prime this LLM, and how that is constituted into a system prompt is something that's not immediately available. There are in fact ways that you can choose to set that. You can sort of put in templates, but that's somewhat hidden from you certainly at the beginner level. If you just use it out of the box, you have to provide the role, the goal, the backstory. And I think this is a really good example of the trade-offs between these different frameworks, because obviously forcing us to think in terms of a role and a goal and a backstory is good, because these are all sort of good prompting practices to think about the context, to give the backstory. This is a good best practice. At the same time, so that's the benefit. The trade-off is that we might have a specific situation where we don't want to give a backstory. That's not relevant. We want to think about it differently. And that is completely possible with CrewAI, but it's going to be harder. We're going to have to then dig in and find out what's going on. And also, if we're trying to debug a problem and we're not sure what's happening, we don't have the same control over the system prompt. We just know that it's being constituted based on these various building blocks. So hopefully I give you this color because I want you to have a good sense of what are the trade-offs in adopting these different platforms. And that's a pretty important one. So a nice feature of Crew is that you can do a lot of the definition of things like agents and tasks using configuration, which allows you to sort of nicely separate some of the text rather than having it embedded all over your code. So when you think about agents and tasks, the two things that make up a crew, agents and tasks can be created by code. You can say agent equals my agent equals agent, open brackets, and then pass in a lot of things like the LLM to use and the role and the backstory and so on. Or instead of that, you can write a YAML file that looks a bit like this. We'll look at many of them in the course of this week, but it's a YAML file. If you're not familiar with YAML, it's a very simple, easy for humans to read kind of markup file, and it looks a bit like this. And this is going to allow us to lay out a role, a goal, a backstory, and an LLM associated with an agent called researcher in this example. And that will allow us to separate out the configuration from the code. And whilst that is, in some ways, as always, there's some pros and cons. The con is that it's a bit of something to get used to. It's some scaffolding. It's specific to Crew. There's definitely a great benefit that this means that you don't have your various prompts buried within your code all over the place. You've got it nicely separated out, and you can work on that somewhat independently. So I think it's a nice touch. In your code, you can then create something like an agent, and instead of specifying all of the fields of an agent, like the role, goal, backstory, you can just simply select the configuration as it shows in this code right here, and they will all be populated for you. So I like it because it's lightweight. It's not like there's magic happening behind the scenes. You clearly refer to the config right there. It's clear what's going on, and it has this nice separation of concerns, allowing us to work on our prompts separately from our code. And then in addition to the YAML files, there are a couple of Python files, and the most important one is called crew.py, and it's where everything comes together. It defines your crew, and it's going to look a bit like this, and we're going to, of course, go and look at a proper example in a second, but it has some decorators over it, and you've got a bit of experience with decorators from last week, and sure enough, Crew has decorators as well, and you can see that there is a few of them. It has crew base is the decorator you put around the whole class that's going to manage your crew, and then there's a decorator agent for each of your functions, which creates an agent, and there's a decorator task for each of your functions, which creates a task. And then there's a decorator crew for your final function that generates your crew. And you can see that it creates an instance of crew, and it returns and it passes in the agents, the tasks, and this thing that's telling it that it is sequential, not hierarchical. It's where you set that important different mode of processing. And you can see that there it says agents is self.agents. And you might wonder, where is that coming from? Well, that's really one of the roles of this decorator at agent, that is making sure that any function that has that decorator, automatically the agent that comes from that will be associated with the instance variable agents, will be added to that list. So that's why you can just simply refer to it at the bottom. So anyway, this will be more concrete when we look at a proper coding example. My main point is that there is this very important module crew, and it's where you define your agents, tasks, and crew, and it uses decorators. One of the things that's really nice about Crew is that it has a very flexible, lightweight approach to interacting with underlying LLMs. It uses a framework called LightLLM under the hood, which it uses to interact with the actual providers and with the LLMs themselves. And I love LightLLM because it's so simple, it's so vanilla. You may know I have a somewhat love-hate relationship with LangChain, which comes with a fair amount of structure to it. LightLLM is almost the other extreme, where there's almost nothing there. You can just immediately connect with any LLM you can imagine. And that really is reflected in the way it's used in Crew. Within Crew, you can just create an LLM, you pass in a model name, and the structure is that it should have the provider's name followed by a slash, followed by the model. And you can just use that to be working with GPT-4o Mini, with Claude through Anthropic. You can use 3.5, 3.7, whatever you want. Gemini Flash, Grok with a Q, and you could also use Grok with a K in the same way. Olama, if you're running the model locally, that's how you'd set it up and supply a base URL. And if you wanted to use OpenRouter, which itself is a kind of abstraction onto other LLMs, but it's an actual service running, then this is how you would configure OpenRouter as an example. But really the idea is very lightweight, very flexible, allows you to really connect and switch around whichever models are running underneath your Crew. And I would argue that in this way, Crew really has an edge over OpenAI Agents SDK, that this is really flexible and simple, and I love it. And so the final topic before we get to do some coding and some crew making is to talk about CrewAI projects. So in previous weeks, we have just been coding within Python notebooks within Cursor, and then occasionally we've gone to real Python modules. CrewAI doesn't work that way. With CrewAI, you do need to work with Python code. And in fact, CrewAI builds an entire project and directory structure for each of your crews. So it comes with a bit more scaffolding than we're used to, and there's a particular way that you need to use it. Now, the CrewAI framework itself is already actually installed because I typed this command here, uv tool install CrewAI. And that means that when you've cloned the repo, you've already got the CrewAI framework right there. But when you want to create a new project, you actually want a crew of your own, you type this command, CrewAI create crew, or my project or whatever, to create that project. And by the way, as a side note, you could say CrewAI create flow, my project, if you wanted to use the flow idea, the workflows, the more fixed workflows rather than a crew. But we're going to be sticking with crews. So CrewAI create crew, my crew. And what that does is it's going to create a whole directory structure that's going to appear immediately. There's going to be at the top, my crew or my project, whatever you call it, and then a subdirectory source, src. And within that subdirectory will be the name of your project again, my crew, whatever. And then under that, it's a bit nested. Under that will be a directory called config, which is where you put your YAML files. And we'll see in particular, by default, there'll be an agents.yaml and a tasks.yaml, which is where we can put our configuration for our agents and tasks. And then there's a module crew.py, and that module is the one I just showed you, which is where it all comes together with the decorators and the place we actually create our crew. And then there's a module called main, and that module is where we actually kick off, we initiate the run. And when we actually want to run it, we just type CrewAI run, and that will actually do that. It will execute main. I think behind the scenes, it just simply does uv run main.py. And that does bring up a good point that this whole thing, when you do this, when you type CrewAI create crew, my crew, it sets up a UV project. Crew uses UV, which is great for us since we're using UV as well. But it makes a project. So you'll also see in this my crew directory, you'll see some of the UV project configuration files as well. So we're going to be having these UV projects within our bigger UV project for the whole course. And that will make more sense when you see it in action. And what better time to see it in action than right now? Let's go and give this a try. And welcome back to Cursor. And here we are in week 3, the crew folder. How exciting. Let's open it up to see what treasures I have in store for you. And it's completely empty. It won't be empty for you, but it's empty for me because this is starting from nothing, the way that some of you like me to do it, which is going to happen this time because that's the way that crew works. So we will begin then by opening up a command line like this, a terminal in crew, which you'll remember is control and the tick on a Mac. That is really the control button on the bottom left. And or it's the view menu and terminal if you're using menus. So then what I'm going to do is I'm going to first change directory to go into the third directory. Right now we are in crew. And I'm going to create a new crew project, which I do by saying CrewAI, create, crew, and then the name of the project. And we are going to call this project debate for reasons that will become obvious, but probably already are. And it first asks us a question. And to read the question, I'll have to make this a bit larger. And this is because when you first create a project, it puts in place, as I mentioned, some scaffolding, some sort of basic project framework. And in order to set that up, it wants to know which model would you like me to start with. So we're not necessarily fixing this, but we can start by saying OpenAI and we can always change it later. Select a model to use and we can choose GPT-4o Mini to keep it nice and cheap. And then enter your key. Now, at this point, we should definitely just press enter because we already have a .env file. It's trying to build .env files for us. We don't need that. We press enter, and you'll see right here that it's created a bunch of files. And I'm going to remove the terminal for a second so that we can take a look at it because they have appeared over on the left. Now, one thing to get in mind is that when you're looking at the Explorer in Cursor or in VS Code, If there's a directory like crew that only has one other directory called debate, then it shows like this. It doesn't bother showing multiple files, multiple folders under it. And that can be a little bit confusing. So we might go back into the terminal and just make a new directory. Let's make a directory and call it other. And when I do that, you see what just happened. Now, if we come in here, you'll see that there's both debate and there's an empty folder called other, which is going to make it a little bit easier on the eyes. Okay, so now let's have a quick look at what has Crew created for us. So under debate, which is the name of our crew that we're about to make, a debate crew, as you've probably guessed, there is a folder called knowledge, and that has a file user preference, and that has some stuff about the person who's the user, and you can change this. This would be background information that would be given to the model if we made use of it, which we will not. So this is a sort of an example of some of the scaffolding that's created in case we need to use it. Then there is a folder called there's a folder called source, and under that folder, there is a single folder called debate. And again, you're seeing it in this way in the Explorer because there are no other folders other than debate under source. So sorry to recap. Under crew, we have a folder called debate, which is the name of the project. That has a subfolder, subdirectory source, src, and that has a subdirectory also with the project's name, debate. And that is where we are right now. And this is the most important directory of them all. This directory named the project underneath source. And that has a few things in it. It has a config directory. The config directory has two YAML files, agents and tasks. And here they are, and they're set up with some default example code in there that we will come back and look at in just a second. There is a tools folder that has just, again, some scaffolding, some basic stuff here that we might want to fill in later that we won't do this time. And then if we come into the root folder of debate, you'll see that there is a file, a module called crew.py, which has a bunch of scaffolding again, and then a main.py. So there we have it. Crew, the module, which is actually the one which brings together our crew, and it has the decorators that I mentioned to you, main, and then the two YAML files under config. That has all been set up for us, ready for us to build our first crew. All right, so we are now going to go and define our YAML, our configuration for our agents and our tasks, starting over here with the agents.yaml file. And this contains some sort of scaffolding, some example agents that are called the researcher and the reporting analyst are the two examples it's given. And we're going to change these to being what we're looking to build. And of course, we're looking to build a little debate team. And in fact, we only need two agents for what we're looking to do. We want an agent that will be the debater. Our one agent is going to play both roles of being for and against the motion. And then we will have a judge. And those will be our two agents. And now we need to describe what they are. And so the role is the first thing that we say here. And we're going to say a compelling debater right there. Okay, and now the goal is what it's looking to achieve, the objectives. And so let's see. I'm going to actually copy across one that I did earlier so you don't have to watch me typing everything, but we're going to present a clear argument either in favor of or against the motion. And the motion is, and this is important, this little thing in curly braces here is where you can effectively make this a template. That is something that's going to get defined when you run this agent framework. When we end up saying CrewAI run, we are going to specify what we want motion to be. And we're actually going to specify that in main.py. So keep that in mind. In main.py, we're going to have to set what is motion, the motion of the debate, the thing that we're putting forwards, the proposal that they will debate. Okay, and so now we have a backstory, which is where we set it's really, we know that this is the system prompt or a big part of it. But in crew land, we want to think of this as the sort of framing of this agent, the backstory. You're an experienced debater with a knack for giving concise but convincing arguments. The motion is so on. So that is the definition of our agent, our debater agent, and that will apply both for one that is presenting for an argument and against it. And of course, we'll be using tasks to distinguish between them. But now let's define our judge. So we are going to give the judge a role, and the role we will say is decide the winner of the debate. Look at how Cursor even suggests what this should be. Let's say based on the arguments presented. Let's keep it short. And then the goal, I will take one that I wrote earlier because it's a couple of sentences. You can see that amazingly Cursor comes up with natural language. It's just great for these things already. So you can even define your agents just by letting Cursor describe them. And the backstory here, I'm going to copy and paste in a nice juicy backstory. And here it is. You're a fair judge with a reputation for weighing up arguments without factoring in your own views and making a decision based purely on the merits of the argument. The motion is blah. So that's the sort of good way to set things like the backstory. And again, on the one hand, one way of thinking about this is that this is the kind of backstory that an LLM is going to take into account in setting the context for this role. The other more scientific way is just to always keep in mind that what LLMs are doing is predicting the most likely next token to follow an input. And the point is that if this backstory is part of the input, then you are increasing the probability that the output tokens will be consistent with this, because things that it's seen at training time that have that kind of backstory often predict tokens consistent with that backstory. So that's the more scientific way of thinking about why this tends to work really well. All right. And then the final thing I'm going to add in here is you can also specify what model to use. And you can just have GPT-4o Mini, or if you want to really spell it out, then you say OpenAI / GPT-4o Mini, but it assumes OpenAI by default for that model. What am I doing here? Model : there we go. Luckily, Cursor to the rescue. And this then is our YAML definition of the agents. Next up is tasks. And now we move on to tasks. And here you'll see that there is a research task and a reporting task by default, but we're going to change this. And we're going to have a few different tasks. We're going to have a task called propose. This is, of course, going to be the task which is about proposing a motion. And so the description, what is this task? It's going to be you're proposing the motion, and then the motion that gets passed in when we do that part. Come up with a clear argument in favor of the motion, be very convincing. Then we're going to have an expected output, which is going to be quite simple. The expected output is going to be your clear argument in favor of the motion in a concise manner. The agent, so this is where you associate a task with an agent, and obviously this is going to be associated with the debater agent. And then there's one other thing we can do here, which is an output file. We want to put this in a subdirectory output, and we will call it propose.md. So there you have our proposal task. So now we're going to have another task, which I'm going to copy and paste, and this one is going to be oppose. This is the debater that's saying no. Description, instead of you proposing, you are in opposition to the motion. Come up with a clear argument against the motion. Looks like Cursor's can help there. It does help. Be very convincing. Your clear argument against the motion, and that should be oppose. It's amazing, isn't it? So Cursor does all the work for us. And now we have our final task, which is going to be called decide. And there's a little tip here. Something which is worth knowing is that you cannot call your tasks the same thing as you call your agents, or you will have a problem with conflicting names. So sometimes it's better to call this like propose task, oppose task. But I've kept it short. But we couldn't, for example, call this task judge. Otherwise, that would conflict with the agent that we called judge. All right. So description. We will say review. Let me see now. Review the arguments. Here we go. Review the arguments presented by the debaters and decide which side is more convincing. And we'll just change this to let's delete all of this. We don't need any of that. We just need to say the expected output is your decision on which side is more convincing. And let's say, and why. All right. And then the this should go, please, to a folder outputs and decide.md, a folder output. All right, that seems good. So there are our tasks. Okay, so the final step really the final steps is setting crew.py and main.py, and then we'll be ready to go. So this is the default module crew.py, and you can see it's got some stuff in here based on the standard scaffolding. It has created a class, and it's got this crew base decorator around it. And this class is named the same as the name of our project, Debate. So it set that for us, and it called it Debate Crew, which is exactly right. Now, one of the things I dislike a bit is that it does generate all of this scaffolding code, all this standard code with lots of comments, and you can read some of the comments and follow the links, and it's got stuff like there's ways that you can add in functions that get called at the beginning and end and stuff like that. But I do find that these comments get in the way a bit, and I usually start by coming through and deleting everything in these just to keep it nice and clean. But what you'll see that it's done that is nice is that it brings in the agents config and the tasks config. It just brings them in from the config folder right here. So those are set as variables for this class, and you can see how it refers directly to our configuration. And of course, that means that if you had different configuration files, then you could bring them in just like that. Then this is stuff about how you can bring in your own tools. And then this is where we set up our agents. So obviously we don't have an agent called researcher. We have an agent called debater. And the @agent decorator is telling crew that this is an agent. It's going to return an agent. The config, we're going to want to change that to debater, and we'll leave it verbose true, which means that we'll get a nice sort of print as it's running with what's going on. And then we'll have another agent. And you remember the name of this guy? Well, even if you don't, luckily Cursor does, and it's filled it in both places. There we go. The judge is our other agent. All right. And now I'm getting rid of the comments about tasks, but it tells you about how you can do things like track outputs and dependencies and the like. But we're going to go on and define our tasks. They have again, the decorator task. And now we're going to have a task called propose. And there we go. Cursor fills it in. Now it has an output file listed there, but we don't need that because it's already specified in our config file. So that's not actually needed. And now that I look at this, I have to say, I think this would be cleaner if we have this all on one line like this. We don't need to be on multiple lines. And now you can see how very simple this whole function is going to look. And look, Cursor's going to do it for us. And then we can just delete that. Sorry, I'm tidying this all up when you see how much better it is when this is in Jupyter Lab and you don't have to watch me doing all this. So don't hate me, I'll be quick, but I think it's nicer if we have it looking nice and sharp like that. You see how nice and simple and clean this is. And that's the benefit of using the config, that we don't need to have too much here. And then the other task is oppose. And obviously it brings in the config for oppose. And then the final one is decide. And there we go. Thank you, Cursor, for filling that in for us. So those are our 2 agents and 3 tasks. And we are down to the final section here. Okay, so we now create the crew, and this is in the function crew, and it has the decorator crew. And I'm going to take out the piece there, which we will be coming to later. So we just simply have to create an instance of crew. We populate the agents with self.agents, and as CrewAI helpfully tells us, this is automatically created by the @agent decorator. We populate it with the tasks that are similarly created. This is where we choose to be sequential rather than hierarchical in our process, and that we want to be verbose. And then there's some stuff about being hierarchical if you want to. And look, if you want to use that nice little comment from the crew team in there. Okay, that's it for our crew object. We're almost finished. That was our crew module. We're now going to the main module where we finish things off. So this is again, there's all of this stuff that you can read. This main file is intended to run your crew locally, so refrain from adding unnecessary logic. Gotcha. So inputs. when we're running the crew, this is where we choose those template values that we put in our YAML file. This is where we choose what we want them to be. And so what we want them to be here is we want to have a motion, and we want to give ourselves a nice motion. We don't have this. We only have the one field, motion. And what motion, what do we think that we would like them to debate? Let's have the motion that is there should be that wasn't where I was heading with this. Cursor, I must be super predictable. But it does seem like a good one to have our AIs debate. Let's not say there should be. Let's say there needs to be strict laws to regulate LLMs. There we go. That's a nice meaty topic for them to debate. And then we've got our stuff down here. We will come back to this stuff. We don't care about any of that. That is all it should take. We should now be ready to run our first crew just based on that. Actually, just before we run, let me make another little change that in this main module, I'm just going to make sure we print the result to the screen just to be satisfying. It will be saved to a file as well. Results equals debate, and then we will print result.raw. That will print the raw output from the final task sent to the final agent. And then maybe one other little change I'll make is I realize we're right now sending both the debater and the judge to be OpenAI, but it'll be more interesting to switch this one up. Let's flip it as Cursor suggests. Let's use Claude 3.7 Sonnet latest, the latest Claude 3.7 model, so that we have Anthropic judging OpenAI's debates. And this also means that we'll be using Anthropic this time, which was harder for us last time. Okay, so with that, now I think we should be ready. We can bring up a terminal. Here it is. We will want to change into the directory for crew and then the directory for debate. And now we simply type CrewAI run to kick off the run. And the first time you do this, it's going to do some UV stuff to build the environment, but I've already done it, so it's running right away. You can see it's executing tasks. The debater, each of the agents is running its debate. Right now, it's the debater for, the proposer has already said, the against is now debating. And now we're deciding on the winner of the debate based on the arguments. It is Anthropic that is thinking. And with any luck, we will soon see whether Anthropic decides for or against the motion. Here we go. Let me see. In evaluating, I found the arguments in favor of the motion to be more convincing. So the view is that there should be strict laws to regulate large language models, such as the very one that is making the judgment here. Okay, so that ran, and look, that's quite a wordy response that came from Anthropic there. You get to see in here the trace of the thinking that happened, and you'll see that an output directory has been created. And if we open this up, and if I close this terminal so it's not in the way, we can go into the output and you'll see that there is weighty argument in favor of LLM law regulation that you can read about the ethical, safety, and social challenges necessitating strict regulatory frameworks, and then the opposing thinking as well. It's no doubt going to be about hindering creativity. Yes, very good. And I'm sure there's some compelling arguments there too. And then the decision is the thing that we already saw printed a moment ago that came from Anthropic. And so that is our first experiment into the world of Crew. We set up our YAMLs, we set up our overall, our module for Crew, the crew.py module, and then the main.py was where we set the motion, which was the thing that was templated in the various YAML documents, and we actually ran our debates with debate.crew.kickoff, passing in the inputs, this dictionary of the templated keys with their values. So I hope you enjoyed our first foray into CrewAI, and I very much encourage you to do the same thing. Well, of course, you will actually see this debate project in there, but you can go and make a second one or just run this by typing CrewAI run and get a good sense for how CrewAI works. And so to recap, we just experienced a CrewAI project, which is in fact a UV project under the hood. We created it by saying CrewAI create crew debate. It created this directory structure, which now should land with you. You should be more familiar. Debate, then source, then debate again, then config. We set up our agents.yaml to define each of the agents, including the model. We set up the tasks that included the expected output and the output file. Crew is where we had the various decorators and we brought it all together with our functions for agents, tasks, and the crew. And we said that the process was sequential. And then we typed CrewAI run within our directory and it kicked the whole thing off, generated the output, and it was successful. And apparently there should be stricter regulation around LLMs. I encourage you to try debating some more controversial points of your liking and choose different models. So yes, we'll of course be getting much deeper into Crew, but in the meantime, the assignment for you is to now play around with this. You could have a separate agent for the agent that is proposing and opposing the motion. Break that into two different agents and have the tasks going to them separately. And the reason to do that is that then it's easy to have a different model so that you could have OpenAI debate with DeepSeek or something like that, and then switch who's opposing and who's proposing to see whether it changes the outcome. And that's an amusing and entertaining way to battle LLMs together to see which are better at forming coherent arguments, persuasive arguments that convince a different model that is being the judge. So that allows you to come up with your own little leaderboard based on debating skills. So please go away and enjoy yourself with that. Get a good handle, get comfortable with the framework around Crew and the sort of minimal scaffolding there. And next time we'll get a little bit deeper into Crew and start building some more Crew projects. I will see you then.